Our next presentation is on hot-in-place recycling, and as best I remember, this is a new topic for the Southeast PPP to have at our meeting. We appreciate that we have Aaron Hansen and Chris Thompson, both from Dustrol, with us.
Like you said, my name is Aaron Hansen with Dustrol Inc. This is Chris Thompson. Jason talked about the cold side of recycling, so I'm going to get a little bit more into the hot-in-place recycling. So things we're going to be talking about a little bit are some HIR benefits, some project selection and candidates, the 3 different types of hot-in-place recycling, and then of course we're going to get into Dustrol's Mars unit. And then of course throughout this presentation, if you have questions, throw your hand up and I'll answer them the best that I can. And then of course we'll have a little bit of Q&A at the end. So what is hot-in-place recycling? Hot-in-place recycling is heating, reworking, rejuvenating the top 1 to 3 inches of the existing asphalt pavement in preparation for either a chip seal, microsurfacing, a Nova chip, a thin lift, or whatever the agency is looking to do. So what are some benefits of hot-in-place recycling? It's going to level out the surface. It's going to remove the surface cracking. Your curb gutter and shoulder heights are going to be maintained. Just like cold-in-place recycling, we're going to reuse the existing paid-for material that's there, and then it can itself be recycled. It eliminates the need for a leveling course, environmentally friendly, and then of course cost-effective. The surface is the critical area. Some things you want to think about for hot-in-place recycling that we look at that we can address are ruts, shoves, patches, utility cuts, reflective, cracking, weathering, bleeding, raveling. We're going to look at a couple different pictures of what hot-in-place can address, and then we're going to look at something that is going to be a little bit too far gone for hot-in-place that might be a better candidate for cold-in-place recycling. Where can hot-in-place recycling be used? We can use them on highways, city streets, county road. The biggest thing we need is a structurally solid pavement. Usually, like I said, hot-in-place recycling addresses the top 1 to 3 inches of pavement, but we need a structurally sound pavement to recycle on top. Some things to think about when you are considering hot-in-place recycling: the uniformity and structure of the existing asphalt, the depths of the existing asphalt, which normally before any project, cores should be taken throughout the whole 10, 15 miles of the roadway to see if you've just got 2 inches above the base or if you've got 12 inches above the base. And that's going to be able to determine a lot which hot-in-place you can do, or if it's even a candidate for hot-in-place. Your asphalt properties, what's there? Is there a bunch of blade cold mix patching there? Is there a chip seal under that old overlay? Is there different patching materials that the state agencies have used? We need to know what's there, because that's going to determine what kind of product it's going to be like once we recycle it. These are some basic distresses that we see hot-in-place recycling address: fatigue cracking, thermal cracking, delamination, longitudinal cracking, oxidation, thermal cracking, rutting, heaving. Rutting from maybe an inch or less, hot-in-place can address. If you've got ruts that are 2, 3 inches deep, you've got a lot deeper underlying issue that recycling the top inch or 2 are not going to be able to address. So if it is a smaller stretch of a rut, an agency can come in and do a full depth patch, cut that out, patch that before the recycle train comes over top of that. And of course, this is some stuff that is too far gone for us to address. That might be a better candidate for cold-in-place, full depth, or a conventional, mill and fill treatment. If there's minor amounts of this on a project that you're looking at for hot-in-place recycling, again, if it's 100 feet on an outside wheel path, you can come in and cut it out, patch it, and then the hot-in-place can come in and it's going to make a uniform look over top of that. So there are 3 different types of hot-in-place recycling. There's surface recycling, repaving, and remixing. Surface recycling is heating, reworking, and rejuvenating the top 1 to 3 inches of the existing asphalt in preparation for either a seal coat, microsurfacing, or an overlay. So this is 100% recycle. This is what we at Dustrol specialize in. Then there are other companies that do repaving, so it's heating, reworking, rejuvenating the top 1 inch of the existing asphalt pavement, and simultaneously applying an overlay while the temperature of the recycled pavement is at 200 degrees or above. And then remixing is pretty similar to surface recycling, but you're incorporating a virgin material into the mix. So if you want to increase the aggregate size a little bit or the gradation, you can add some rock, or you can just add 30 pounds or 90 pounds a square yard of virgin material into the windrow while the hot in place recycle process is going. But we're going to talk a little bit about these. So these are some pictures of Cutler Repave. They are based out of Lawrence, Kansas, and they are a repaving company. So you can see here, you've got your basic propane tank. You've got a heater bed underneath that's heating and softening the asphalt. This here is also what we call a preheater. It's purely just heating and softening the asphalt. And then before the last unit, there's your hot mix truck putting it in. You've got the heater here. Then there is a scarifier here that's scarifying the top inch of material. Then some kind of rejuvenating agent is added to the inch of material here. The brand new virgin hot mix is dropped on a conveyor, taken above the material. The recycled material is striked off. The virgin hot mix is dropped right behind it, striked off on an inch, and then it's compacted at the same time. And this here talks about what I just talked about a little bit more. So it's heating the existing pavement, scarifying an inch. It's applying a recycling agent to the scarified material. It's mixing and laying the recycled material, and then applying the virgin hot mix overlay at the exact same time, and then it's all rolled and compacted together. This is just another picture of the repaving train. You know, depending on the asphalt, the PG grade, you might only need 1 or 2 preheaters. You know, on this project here, they felt that they needed 3 heaters to soften the asphalt before the last repaver with the scarifier. You can see this train is a little bit smaller. It can address curb and gutter in town where some other hot in place treatments are not very suitable for in-town curb and gutter. Here's another picture here. You can see the recycled material getting striked off, the virgin material dropped in behind on top of that. One thing with repaving, if you are addressing a boulevard or something with curb and gutter, you might want to think about edge milling, 4 to 6 feet. So when that inch overlay goes on top of the material, you're not going to have any buildup on the curb, and it's going to be flush with the curb and gutter. Some agencies don't care about that, and I know others that do. So now we will talk a little bit about remixing. It's combining an admix or asphalt or aggregate within the recycled process. So it's basically the same thing. You have a certain amount of preheaters, a scarifier, or it's being hot milled, and then you have virgin asphalt being added to the windrow through a pug mill or some other kind of. This is our pug mill out in Denver, Colorado. When it comes to our hot in place recycle process, out of the 12 states that we will be doing hot in place recycling for this year, Colorado is the only state that requires us to add admix. And you can see here the truck there dumping into the hopper, and then it's coming out at maybe, I'm not sure what this project was, but say 40 pounds a square yard are being added into that windrow. Say you add 90 pounds a square yard into your recycle process, you should be expecting to, increase the about 3/4 of an inch of the road. Where most recycles, it's going to be flush and the exact same it was before. So now we're going to get into surface recycling. Now this heater scarification, there are 2 different kinds of what I consider surface recycling: scarification and hot milling. Scarification has been around since the 70s. Dustrol started doing heater scarification in the 80s, and we did heater scarification all the way up to the mid-2000s. And then we built, engineered, designed what is called the hot mill process. So we were the first to do it in the United States. There has been another company that's followed suit since then. But heater scarification, you're heating the surface to approximately 300 degrees. You're scarifying the soft asphalt at a depth of 1 inch. Then you're adding an engineered emulsion meter to design content. And that brings me to something I don't want to forget. On all these hot in place projects, there should be a core, for our process, if we're doing a 12-mile project, we are taking 60 cores throughout that project to get it, then we take it into the lab and get a balanced mix design. If your agency is looking at doing any of these kind of hot in place recycle, there should be cores done. There should be a full mix design done on every single project. Then the recycled material is mixed and it's laid down with the paver, it's compacted. And with all these processes, like you saw with repaving, it's getting a thin HMA overlay on it automatically. With surface recycling, it's going to be any kind of surface that you see. You know, across the Midwest, we see Nova Chip or U-Boss, we see thin lift, we see chip seals, we see micro. You know, it's really whatever the agency, or in some states, it's whatever that district really likes. One state might be doing Nova Chip, the other state might say we're never doing Nova Chip and all they care about is doing chip seals on top. It's just your preference. But of course, a lot of things that go into that are the traffic. If you're on an interstate, you know, I-40 through Oklahoma, we might need to put a 2-inch overlay on top of the recycle versus in western Kansas, where it's got 500 farm trucks a day, you can get away with a single layer chip seal. Again, these are all just preheaters. You know, this is set at 13-foot, propane tanks on top. I like to think of it like a brick oven. It heats, softs the asphalt. Again, soften the asphalt, and then you're scarifying here. Pictures of the tines going down, breaking up the asphalt at 1 inch. This is the paver that we use when we do heater scarification. The emulsion is added here, and then it's got a milling drum here that mixes the inch. Then there's an auger that mixes it, and it's striked off with the vibratory screed. When it comes to heater scarification, there is a company out of Chicago called Gallagher Asphalt. They're based out of Chicago, but they travel all over the United States and do that kind of work. Also, a new company that's just got started the last couple years, Garrity Asphalt, based out of Connecticut. They do some work in that area. This is just a picture from last year's heater scarification project we did in Kansas. Now we'll get to what Dustrol calls the MARS unit, the mobile asphalt recycling system. And it's basically we go 2.5 inches deep, and instead of scarifying, we're using milling drums like you see on a milling machine, so we call it hot milled. All of our equipment is manufactured, built right in Towanda, Kansas, which if you know where Wichita, Kansas is, it's about 20 miles east of Wichita. So with our hot in place recycling MARS unit, you can see in the top right, it's not a small train. There's 8 units in our train. We stretch out 900 foot long. The asphalt is heated just like all the other processes, but instead of scarified, it is going to be milled off in 1/2 inch increment down to the desired depth. Again, an engineered emulsion is added. The material is mixed in Windrow, then laid down with conventional paver, vibratory screed, and compacted. And I'm going to pull up a quick video from a project last year in Tennessee. So this was a project in Tennessee. I believe this year will be our 6th or 7th year doing hot in place recycling for Tennessee. Again, here you can see we're going down the train. Every other unit in our train has what we call the milling drum. There's an 8-foot drum and 2 4-foot milling drums that are all set up with a string line ski system. We can adjust those. We can do 12-foot passes. We can stretch all the way out to 16-foot. Now that just doesn't, we can't just hit a button and that adjust. You know, it takes some turning wrenches at night. So, you know, if you're wanting to address a 12-foot lane, just go white line to white line, we can address that. Or say you're wanting us to go 14-foot and get past that rumble strip, or we can stretch out 16-foot and get as much of the shoulder if you want. Like I said, every other unit in the train has the milling drums. Then these last 2 units here are what's metering the emulsion. That's metered in at a design content. It's remixed here, picked up with the conventional paver, and off we go. And after this video, we're going to go a little bit more into each piece of equipment and break it down a little bit more for you. That's just a quick overview of our train. So like you saw in that unit, there's 8 units in our train. The first unit is what we call a preheater. Now this is purely just heating and starting the process of softening the asphalt. The second unit in our train is what we call a heater mill. Like I said, it's got an 8-foot milling drum, then 2 4-foot milling drums with a string line ski system on each unit. And that's taking the first ½ inch of the material off. The next unit is what we call...
One of the reasons that we do a preheat and then a heater mill is to, we actually heat the road twice before we mill it. And that's to ensure that we don't cause any degradation to your existing aggregate. Like you may have a Nova chip or PFC where you have all that Class A aggregate that you've already paid for. That was a substantial cost when you put it in. We're bringing this up hot, so we're not degrading your existing aggregate. And we'll actually do this 4 different times before it goes back into laydown. And that's just a really pretty important point. Because we are equipment intensive, labor intensive, we move fast. We move 25 to 30 foot a minute, which equates out to 2.5, 3 miles per day. We like to work on the big heavy highways, get down the road, close off our lane to traffic. We don't have anything coming in or coming out. We never stop once we start. We refill our emulsion on the fly. We add water on the fly. And it's just keeps us going all the way. So what you'll see, that's a windrow coming out right in here. So we go through and we take off, we preheat it, then we mill heat it. And then you see a windrow is probably a couple inches high. And that windrow grows the entire time till when you get back to your coal cow, until it looks like it was just coming out of a live bottom feed. The emulsion's added in the last 2 units depending upon the content, and you can see over the meter right there tells us how many gallons we're using through the day. And like I say, that's all. We use 2 different emulsions, an ARA 1P and ARA 2P. The biggest difference is that the 2P is a little stiffer and has more polymers. As we move up north, we find that usually there's a lower binder grade, and that's more specific. I work primarily in Texas. We use 1P, but our binders are a lot harder. We use the 70, 76 minus 22 or whatever. We're up north, it's typically a 60 and other things.
So then there's a picture of it coming out behind the last, where the emulsion's been added. It's coming out in a windrow. It's going to be picked up with conventional elevator, and then it's striped off with a vibratory screed. Now a little bit different with the paver we're using. We call it a remixing paver. So when it's picked up in the elevator, it's dropped into the hopper. There's 2 augers in the hopper that are continually remixing the material, and it's augered all the way back to the screed, and then there's also an auger in front of the vibratory screed. We just get a lot better mixture and reduce segregation with this paver. And then just like on an overlay, we're going to set up a rolling pattern to reach densities. One thing a little bit different, who's familiar with an oscillating roller? Has anybody seen it or started maybe looking to putting those on some of your projects? All of our crews use an oscillating finishing roller. So instead of, if you've seen these or been by it, we're able to reach increased compaction at lower temperatures. It needs it back and forth inside of that drum instead of pounding up and down. Now we're just going to go through a couple before and after pictures from some projects the last couple years. Some benefits, I guess we'll go through first. No segregation from dump trucks. The HIR train continually moves, like Chris said. We never stop throughout a day. We might get 2.5 to 3.5 miles done a day without stopping. So there's no joints throughout the day. Hot edge joint. I think a lot of people see centerline pothole problems in different states, right? When we go down a southbound lane, when we come back north, we're going to overlap that center joint 4 to 6 inches. So you're going to have a nice hot center joint there. Lane closure, just like with cold in place, once it cools down in an hour or 2, you're going to be able to open up traffic to it. And then, of course, the next morning, we're going to divert traffic and set up our traffic control the next day. Again, like I said, these are just some different treatments that different states have put on top of hot in place recycling over the years. Just like cold in place, the traffic amount, the kind of traffic, the structure all goes into factors into what you should put on top of your hot in place. This was a project recently in Missouri, Highway 54. This had a Nova chip or a U-Boss put on top of it. This was Texas 287 by Amarillo. Chris, this got a thin lift on it, correct?
It did get a thin lift. We call it our TOM, thin overlay mix is what they put on top of it.
This was Lexington Highway 22 in Tennessee last year. Tennessee 2015 pictures. And these are just going back over all the summary, everything that we've talked about. The biggest thing probably, we're cutting trucking down just like a cold in place by probably 90%. The greenhouse gases, we're probably dropping that, eliminating that by 30 to 40% compared to a conventional treatment. And then probably the biggest thing that I think agencies look at is cost savings, is stretching the taxpayer's dollar out. Depending on what you're paying in your state, your area, normally we're saving an agency 30 to 40% on that project. You saw how big our train was. We usually don't just come in for 2 or 3 miles. We're looking for probably a minimum of 10 miles to come in. Chris does a lot bigger projects in Texas that are 30 or 40 miles long. And you can see there the cost savings on a big project like that, what it could be for an agency.
When I do a project in Texas, I typically, our cost savings versus a straight mill, seal, and fill is probably 35% is what we do. And then one of the other questions we get all the time is, why did Dustrol, why did y'all come up with this technology? Because we do the scarification. What we found is on a lot of the state roads and everything else, that because of the seals that everybody's using, your chip seals, your Nova chips and everything else, that we could not get down to the asphalt with the existing scarification. So that's why we went equipment heavy. And there are times where we will actually throw a 5th milling heater out in there to go the 2.5 to 3 inches deep. And about 3 inches is about the limit of what we can get.
You said you require at least 10 miles, for example, you 30 miles. So that road have to be a nice, long, straight road. What about curved roads?
We do good curves, and we do this in Colorado, Texas, Nebraska, and several other states, and so we can pull a grade too. A lot of the work I do, last year we were pulling 7% grades out in West Texas up and down the mountains. I mean, we're not going to make a curve on a cul-de-sac, but yes, it doesn't have to be perfectly straight.
I forgot to, on our equipment, you saw the back end of the units have dualies. We can pull a pin, and the back end of those units will pivot just like you see on a fire truck.
My next question is, what do you do to check that whether a job is done right or not? The density you're checking, or taking
we have
cores?
specifications, so we pull cores every day. We have to meet a density spec, a Hamburg spec, or an APA spec. Some states require an overlay every day, but we have QC, QA every day on the job throughout the day.
Any work on blending between existing binder and a rejuvenator that you are adding?
Yes.
That too?
We do a full engineered mix design before the project.
Okay. And what is typical density for this type of?
My spec is, and that's what I work with the most, is I look for about 6 to 7% air voids is what I'm trying to get. My Hamburg, which is your APA, is I have to be less than 12.5 millimeters at 10,000 passes. I'm typically around 4 as far as my rating is what my average job comes in at.
And one thing to think about with our specific hot mill process, we're milling that road 4 different times. We're smoothing it out 4 times before we lay back on top of it. And that's why we are able to improve the ride so much. Previously, the last couple years, Tennessee project a couple years ago on 412 got smoothest road in the state award that year. Of course, it did get an inch overlay on top of it, but I would like to think that them laying on top of us had a reason for that.
Absolutely.
But we don't get any credit for that.
Yes, sir, in the back. Production rate, like we said earlier, that we can get 2.5 to 3 miles per day, but production always based upon the road and what the material gives you and how it compacts. I mean, you can't outrun. I can run the train at 40 foot a minute, but then I'm going to outrun my rollers. So I would say your typicals can be 25 to 30 foot per minute.
And a lot of factors go into that. Probably the biggest thing, heat is the key to our process. Most state specs are 50 degrees and rising. In Texas, things got to be 60 degrees and rising. You know, if it's 105 on July 4th and that asphalt is already pretty hot, we can get going a little bit versus the end of September and we've got a 20-mile crosswind. You know, we're losing a lot of heat, so we might only get 2 miles.
Yeah, 17 foot a minute.
So,
it depends. There's a lot of factors that go into it.
And of course, asphalt in every state heats differently than somewhere else. So there is a lot of factors go into that.
Yes, sir. Yes, that's where we do the mix design. The ARA1P has rejuvenator and polymers added back into it, and so we take our cores, we plug mill them all down, and then we start making the bricks and running everything in the lab. And so we will submit a engineered mix design before the job to be approved.
He just asked if what's the ARA. It's a specially designed emulsion that's just for our hot in place process. Ergon Asphalt Emulsion is our main supplier, and years ago they helped design and engineer and come up with that. I couldn't tell you all the chemistry of what's in that.
No, actually, and that's a good question, because there is crack seal, and just because I take the cores all the time, you'll have crack seal that is in the road, and it may go down 2 inches, it may go down 3. Normally that's not what I see on a lot of it, especially after it's been down. I mean, because I'm getting to a road that's typically 12, 15 years old by the time I get to it. As we go through and heat it, since it's distributed and mixed so many times, it's just spread out through the mat. But the other thing is because it's heated, the heat causes it to run down to the very end of the crack. And so it actually helps when we do that.
Yeah, there's there's 8 heaters in our train. So by the time we get back, that's fully emulsified and mixed in with everything else. But that is, that's something where your hot in place contract in the area should be willing to come out and look at the road before you core it and be able to tell you we can do this, or actually you need to look elsewhere. I mean, that's kind of Chris and I's job.
Yeah, it is not a fix-all. It's not for every road, but for the right road in the right place, it can save a lot of money. No, we don't. Typically, we just want to cure out at least 7 days. We've never experienced any problems of having to do that. I'm sorry, I can't hear you. Let me bring in the microphone. I apologize.
Yeah, in the preservation world, when asked a question about new asphalt patches before a microsurfacing or a chip seal goes down, there's a certain amount of time to wait before it goes on top, so that new patch doesn't soak up the emulsion of either the chip or the micro, making the overlay thin, bony. They like to wait a longer time before they do their patches, and we advocate that. So my question is, if it's to be done in succession in a short period of time, I would think it would be more beneficial to choke that off with some sort of sealing agent, such as a fog seal, before that preservation treatment goes on top of it.
No, because you're talking about patching the road before
No, with any new asphalt, if you're going to put a microsurfacing on top of it, right?
Right.
Okay. We want to be able to choke that off so the new, whatever you've just done does not soak the emulsion out of the treatment that goes on top of it. Am I stating that right?
Yeah. You're wanting like a tack.
Like a tack or a fog or something of that nature.
Yes, they do need to do that.
Okay.
Absolutely.
Yeah, that's what I was trying to say.
Sorry, we didn't understand each other. Any other questions?
People my age remember hot in place from quite a long time ago, and we had issues with blue smoke from overheating of the surface asphalt. So I want to know, what has the industry done in the last, oh gosh, I don't even want to say this, but probably 25 years to really control that environmental issue?
And you saw why we have so many units in our train. We slowly, gradually heat the asphalt. Those heaters don't just sit right on top of that certain, 13, 14 foot and really cook to get it to 300 degrees. We slowly heat it throughout the process. And that's been over years of experience. We realized that's why there's 8 units in our train. Chris, you want to add anything to that?
Well, the other part, and because experience is the greatest teacher of all, is I do know about the smoke that you're talking about. is I will never, ever, ever recycle a road that has a tire rubber seal on it again.
And then if you're interested in coming to a project, we'll be working in Tennessee and hopefully Kentucky this year out east. Thank you.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.